Determine the equivalent resistance of the network between points P and Q. So if we consider this part here first, obviously they're in parallel, so we'd say 1 over RT is 1 over R1 plus 1 over R2, so it's 1 over 30 plus 1 over 60. So my common denominator would be 60, so this goes into 60 twice, so I've got 2 60ths plus a 60th, which is 3 60ths. Okay, so if 1 over RT is 3 over 60, then RT over 1 is 60 over 3, which is 20 ohms. So this part here, the equivalent resistor, would be a 20 ohm resistor there. Okay, now if we do this for here, the 30 and the 15 are in series, so they add up to 45 ohms. Okay, so we've got a 45 ohm resistor in parallel with a 90 ohm resistor. So for those, we'd say 1 over RT again is 1 over 45 plus 1 over 90. Now, if we look at our common denominator, this time it's 90. 45 goes into 90 twice, so it's 2 over 90 plus 1 over 90, which is 3 over 90. Again, that's 1 over RT, so RT over 1 is 90 over 3, which is 30 ohms. So an equivalent resistor for this part would be a 30 ohm resistor. So we'd have a 20 ohm and a 30 ohm in series, so we could add them together and that would give us an equivalent resistance of 20 plus 30, which is 50 ohms. Okay, the next one says if the current through the ammeter is 50 milliamps, calculate the total charge that flows through the resistor in 4 minutes. So the equation we use here is Q equals IT. So Q equals the current, which is 50, but it's milliamps, so it's times 10 to the minus 3 times 4 minutes, so it's 4 times 60. So that's 120, 245 is 12 coulombs. Okay, so the charge that flows is 12 coulombs. If 18 joules of energy are transferred to the resistor R in this time, calculate the potential difference across R. Okay, there are a couple of different equations we could use here. We could use E is VIT, or E is VQ because Q is IT. Because we've just worked that out, I'd use the bottom one. So I'd say it wants the potential difference. So I'd say V equals E over Q. The energy is 18 joules. The charge we just worked out is 12 coulombs. That means the energy is 18 over 12, which is the potential difference, V is E over Q, which is 18 over 12, which is 1.5 volts. Calculate the resistance then of R. Well, R equals V over I. The voltage is 1.5 volts across R. So we're just looking here, and we've said, okay, the voltage here is 1.5. We know the current is the same everywhere because through here, because it's this part of the circuit's in series, we know the current is 50 milliamps. So we know it's that divided by 50 times 10 to the minus 3. So 1/2 3, 30 ohms. And then it says, what's the EMF of the battery? There are several ways to work this one out. I'd probably use V equals IR, because I know the current is 50 milliamps, so I'd say 50 times 10 to the minus 3 times R. Now, we've just worked out that this resistor here is 30 ohms. We know the equivalent resistor there was 30 ohms, and the equivalent there was 20. So if we added all those together, because they'd all be in series, we'd have 30 plus 30 plus 20, which is 80. So I'd have 80 ohms there. So 55, 80, 44 volts. Okay, so the EMF would be 4 volts.